Okay, this is our presentation for our 3D navigation demo. This is made by Hong Yu and Lowell Novitch. So, in this PowerPoint, we'll quickly go over 4 sections, which will be the 4 parts of our project. So we're first going to talk about voxelization of the 3D space. So our project was made using the Unreal 4 engine. We started with a free plugin called DON Navigation to generate our 3D voxel space. These voxels have the 6 standard degrees of freedom and 12 combined from these 6 for movement to get our neighbors. Finally, we used Euclidean distance to calculate the heuristics for the search algorithms. So the first algorithm we're going to talk about is A star. For plain A star, it can be split into 3 sections as shown here. By using a priority queue, you can remove the need for an open list, and as you won't need to remove the nodes from them anymore, you just dequeue. As you see, this is a standard A star. We only need to change one bit of this pseudocode here in order to get our very next algorithm, which is Theta Star. As you can see, the change here is in the compute cost. In A star, we can use rubber banding to optimize our results. We apply a line of sight check, and we can remove unnecessary waypoints from our solution. In Theta Star, we also use that line of sight test, but it's done during the cost calculation step. As you can see here, we check the line of sight from the parent of the current node to the next node, which means if they have a clean line of sight, we don't need to calculate cost based off of the current node. We can calculate it based off our parent node and treat our parent node of this node as the parent of the next node. And this can be applied to all angles, unlike A star, which only can be done from the normal step angles. But since line of sight can be expensive, if we remove it from the cost calculations, we get our next algorithm, Lazy Theta Star. So, Lazy Theta Star assumes that line of sight is just satisfied, and if not, it will find the lowest cost neighbor, just like A star. So, we look at set vertex here. The logic for it might look a little complicated, but it's actually very simple, because S is a vertex from the open list. Therefore, it must have a neighbor, at least one neighbor, that expands to it from the closed list. Therefore, we can easily just backtrack if line of sight is not satisfied. We don't have to use it. We could just use A star. So that's a quick overview of everything beforehand. So now we're going to go pop into our demo. So here's our demo, and let's go quickly over all the things here at the side. So you can select our algorithm here. We could turn on and off the visualization of the open list and the closed list. We can set it to move or no move. Preset is preset positions to show off various cases for the algorithms. Reset agent is for cases where, we'll get to that one later. So we have randomize goal, which will randomly set the goal to a random location within the bounds of here, possibly even a location inside a wall. And finally, set goal at camera, in which case it will set the goal to where the camera is as long as the camera is inside the grid space. It will warn us if not. So let's start with the first preset here, and let's do no movement and no visualization. So we can start. You can see gets us our path all the way over to our goal. So let's try Theta Star, and this time we're going to visualize the closed list. Start. See this green nodes here. This It's our closed list. And then, of course, it gets rubber banded over to here. So let's do Lazy Theta Star. Let's do the open list for Lazy Theta Star. Start. See? Moves its way over here, all the way down here. But what happens if we want to move along this path? So, you just move along it. Brings us to the goal. Or we could reset all the way back to the beginning and like, I want to see Theta Star. See, just moves along here. Reaches the goal. Let's try the second preset. Let's visualize both closed space closed list and the open list. Here, all the way up here to the goal. Shows it can kind of go anywhere. Next one, let's do Lazy Theta Star. Let's go to our third one. Okay, start. Hit C, time elapsed, which has been showing this entire time, and notice, even though we visualized the open list and the closed list, none of it showed up. That's because there's a direct line of sight from the start to the goal, which means it can be done instantly in a single step. We don't need to do multiple ticks. This is an optimization we've put into our algorithms. Let's do the last one. A star, start. Time elapsed. Moves along the path, does some movements, and here we go. Here at the goal. So now, let's randomize the goal. Let's randomize it a few times. I don't know where it is. Start. Found the goal. Let's see. Right here. Now, let's set the goal all the way over here. And let's do Theta Star. Start. And it made it. And that's everything our project has.